All right, in this video I'm going to show you how the law of sines works. Again, I'm not going to prove this. I hope you'll see that somewhere else, or maybe you can go watch another video and look at it. With 2 days left in the school year, we just don't have time to go through that proof right now, but it's on the interwebs. You can find it. Anyway, the law of sines uses a relationship very much like what I showed in my law of cosines video. If you have triangle ABC labeled any way you want, label the side opposite angle A with a lowercase a representing the side length. The side opposite angle C with a lowercase c representing its side length, and angle B is opposite side length B. Turns out that the ratio between side A and the side of angle A is the same as the ratio between side B and the sine of angle B, which is the same as the ratio between side C and the sine of C. Okay? In general, if you have a side length and its opposite angle, and you know those two things, and then elsewhere in the triangle you have another pair of an angle measure and a side length, you know one, you don't know the other, the law of sines will probably work. Now I do have to warn you, there's something called the ambiguous case that applies to situations in which you have an ASS or an SSA setup that you can get multiple answers. I'm not going to deal with that in this video, just kind of trying to do basic stuff here. But anyway, so this example here, let's try this. So if you're trying to figure out, do I use the law of cosines or do I use the law of sines? Again, law of cosines, typically you have two sides that form an angle, okay, is the most standard setup. You usually have pairs of opposite sides and opposite angles when you have law of sines. So notice here I have an angle, I have its opposite side. I have another angle, I want to know its opposite side. Okay, we have two pairs. That's the kind of thing that we need here. So very simple formula to use. And again, it doesn't really matter which is side A and which is side B. It just basically says a length of a side over the sine of its opposite angle is going to be equal to the length of some other side over the sine of its opposite angle. Okay, so we've got 12 matched up at its opposite angle of 65. We've got x matched up at its opposite angle of 35. We just solved that equation, okay? Once again, you want to be in degree mode on your calculator. So I'm going to take 12 times, I'm going to cross multiply here. 12 times the sine of 35 is equal to x times the sine of 65. So I'll take 12 times the sine of 35 here. And that's about 6.883, which I'm going to leave in my calculator. That's equal to x times the sine of 65. So I'm going to divide both sides by the sine of 65, okay? And if we do that, we end up getting approximately 7.59, okay? So this side length here would be about 7.59. And if you look at the problem, this should make sense, right? A larger angle is going to be across from a larger side. A smaller angle is across from a smaller side. So, you know, not something you can do in your head, but at least you can kind of think about whether or not it makes any kind of sense, okay? So that's kind of your basic law of sines setup. Let's try another one. So you can also use law of sines to find angle measures as well. So for example, let's say that this side length is 6, and this is 7, and let's say this side is 4, and let's say I have a 30 degree, let's not make it a 30, let's make it a 32 degree angle, and I want to find this angle measure over here, okay? Same kind of thing, as long as you've got pairs, a side and its opposite angle, and another side and its opposite angle, as long as only one of the things is a variable, you should be able to set up an equation. So 4 and 32, those match up. So I can do 4 over the sine of 32 is equal to, and then I want this involved, so I have to have it with its opposite side. So is equal to x over, oh, I'm sorry, the side length is 7, over the sine of that x degree angle, okay? And again, you just cross multiply and solve, not terrible. In this case, we get 7 times the sine of 32 is equal to 4 times the sine of x. So I'm going to take 7 times the sine of 32, and I'm going to divide by 4, okay? So 7 sine of 32, divide that answer by 4. And I'm going to get about 0.927 is equal to sine of x, okay? Once again, we're trying to find an angle measure, so you're going to need that inverse sine, sometimes called the arc sine. So I'll take the inverse sine of 0.927. And again, I'm going to use the full number that's in my calculator instead of rounding, because you don't really want to round during the problem. And anyway, we're going to find out that that's about a 68.03 degree angle, okay? And again, if you look at the numbers in the problem, you should be able to kind of see if everything looks right in relationship to each other. 32 is smaller than a 68 degree angle. It's opposite a side length of 4. 68 is a bigger angle. It's opposite a bigger side. So in general, the numbers all seem like things that would make sense for this particular situation. So that's the law of sines. In another video, we've also seen the law of cosines. Two pretty powerful ideas that will allow us to do some work with trig with triangles that are not necessarily right triangles, although these will work if you have right triangles as well. So if you haven't seen those before, hope you have kind of an idea about how those work.